This video is on intermolecular forces. Intermolecular forces are forces of attraction between molecules. We know intermolecular forces exist because we have solids and liquids, which means these molecules that comprise a solid and a liquid have to be attracted to each other in order to form a solid or a liquid. Otherwise, they would be a gas. So we know they exist. We're going to talk about van der Waals forces and London's forces. They're the same force, discovered independently by a Dutch physicist and an American physicist. The Dutch was van der Waals and the American physicist was London. So these are very weak intermolecular forces of attraction between molecules or atoms. So we're going to just do an example of this. I've drawn 4 atoms here, and we're going to look specifically at neon, just because it's easy. Okay, and neon has 10 protons and 10 electrons, and we know that the protons are in the middle, and it has 10 electrons scattered about. Now, I'm going to be ridiculous and put 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're also going to know, we know that gas molecules are moving about and colliding with each other, so I'm going to put these in a collision course. Finally, I know electrons move. And so what happens is, if I take this electron over here and I move it to that side, I end up with this situation. I end up with, I'm dividing it up, 4 electrons on this side and 6 electrons on this side. So this side is going to be partially negative. We're going to be partially positive because the electrons aren't distributed evenly. So what's this do to this molecule over here, or this atom? Now this atom is sitting here with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And now we have a positive charge, so it's going to attract an electron from our right side over to our left side. And so we end up with 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. And we end up with an induced dipole induced by this atom here. It's induced by that atom. And so we have an attraction from the positive side to the negative side. So these partials attract each other. I got partially negative here and partially positive over here. They attract each other, and this makes a very weak intermolecular force that we call London's forces. It's in everything, and it depends on the motion of electrons. So in general, the bigger a molecule, the larger the intermolecular forces, the larger the London forces. I'm going to call them London all the time, but they're also called van der Waals forces. The larger the London forces. That's the first rule. The second rule is that the more linear a molecule is, the closer they can get together, and so the larger the London forces. So if I draw a molecule as like a stick, this would have 1, 2, 3, 4, 5, 6 atoms. This one would have 1, 2, 3, 4, 5, 6 atoms at each corner. Atom, 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 atom. And we'll talk about this as drawings later. This one would have more intermolecular forces. So the more linear they are, the stronger the intermolecular forces.